Hello everyone, my name is Divya Singh. I'm a third year B.Tech student at MIT Academy of Engineering. Today, I'll be presenting on the topic optimization of loss function and best fit line using gradient descent. So, let's begin. To begin with, let us understand the concept of regression. Regression is a statistical method used to analyze and model the relationship between two variables, a dependent variable y, which we want to predict, and an independent variable x, which is used to make the prediction. In linear regression, we assume that this relationship can be represented through a straight line. So, regression is used for prediction, forecasting, and for analyzing trends. The equation for this is y equals mx plus c, where y is the predicted value, x is the input variable, m is the slope of line, which indicates how much y changes when x change, and c is the intercept, which tells us the value of y when x is equal to 0. So, in simple terms, if we know the input x, regression helps us to predict the output y. To better understand this, let us take a real life example. A student records how many hours they study and their corresponding exam scores. As we can see in the table, we have hours studied in X and exam score in Y. So looking at this table, we observe a pattern. As the number of hours studied increases, the exam score also increases. So there is a positive relationship between study time and marks. So now, using the linear regression, we calculate the equation y equals mx plus c, where m is equal to y upon x. So we get the equation y equals 5.05x plus 46.4. This tells us for every one additional hour of study, the student's score increases by about 5 marks. Also, if a student studies 0 hours, the expected score is around 46 marks, which now if we plot these data points on a graph, we notice that the points do not lie perfectly along the straight line. This is normal because real world data is never perfect. However, when we look at the overall pattern, we can still see a trend. And this is when the concept of best fit line comes into picture. So the best fit line is the line that best represents this trend. It does not pass through all points, but it is the line that is closest to all the data points collectively. So the goal of regression is to find the values of m and c that creates the best fit line, which explains the relationship between x and y most accurately. But how do we measure whether our line is accurate or not? For this, we use something called as the loss function, also known as the cost function. So the best fit line, as we know, should be close to all the data points. And to measure how close these predictions are to the actual value, we use the loss function. So the most commonly used loss function in linear regression is mean squared error. So the mean squared error MC is calculated by 1 by n summation of y minus y cap the whole square. So this formula measures the difference between the actual value y and the predicted value y cap. It squares the difference to avoid the negative errors, and then it takes the average. Now that we understood what loss is, we must ask, why do we need to optimize the loss function? So as we know that the loss function tells us how far our predictions are from the actual value, and when we first choose the values of m and c, they cannot be always correct, which means that our prediction will be inaccurate and which could cause us high losses. So if the predictions are very close to the real values, the MSE becomes low, which means it is a good fit. And if the predictions are far from real values, the MSE becomes high, which means it is a poor fit. So our objective is to minimize the MSE because higher the loss, there would be poor prediction, which means that our model would be inaccurate. So to improve this prediction quality, we must reduce the loss. The process of reducing the loss is known as optimization. So optimization helps us find the best values of MNC for the best fit line. Without optimization, the line may be too steep, too flat, or shifted incorrectly. Therefore, we need a systematic method to find the minimal loss. And for this, we use the algorithm called as gradient descent. So gradient descent is an optimization algorithm to minimize the mean squared error. It works by iteratively adjusting the values of M and C in the direction where the loss decreases. So the formula M equals to M minus alpha delta J by delta M and C equals C minus alpha delta J by delta C. It works like this. We start with some initial guess for M and C. We calculate the loss. We look at how the loss changes if we change the values of M and C, which is called as the gradient. We then update M and C step by step in the direction that reduces the loss. This is similar to standing on a hill with walking downhill while we reach the lowest point. Also, as we can see in the formula, alpha, which is also called as the learning rate, it controls the step size. And the partial derivatives, delta G by delta M and delta G by delta C, tells us how the loss change with respect to M and C. So the method for calculating gradient descent is we initialize the value of M and C by any random value. We compute the predicted value by using the regression equation, which is y equals mx plus c. We then calculate the loss, which is mean squared error. We find the gradient, which is the slope of the loss curve. We then update the values of M and C, and we repeat the whole process until the loss becomes minimal and stops changing significantly. Also, talking about the significance of the learning rate, the learning rate alpha controls how big each step is during the descent. If the value of alpha is very low, it means it may take very iterations. And if the value of alpha is very high, that means it is oscillating and it is unstable. So let's see an example of gradient descent. We have the same example as we took previously, which is hours studied in X and exam score in Y. So following the method of gradient descent, we initialize the value of M and C, calculated the value of Y using the regression equation. We found the value of MSC using the formula 1 by n summation y minus y cap the whole squared. We find the gradient values with an updated M and C using the formula, and then we repeated the process. Finally, at the final value of M and C came out to be 5.11 and C equal to 45.85. Hence, so the final optimized regression equation would become y equals 5.11x plus 45.85. And this becomes the best fit line that minimizes the overall error. Talking about the real world applications, it can be used in business and sales to predict the future sales, understanding the price and demand trends. It can also be used in education to analyze the student performance patterns. In weather forecasting, for regression model would be used to estimate the temperature, rainfall, and climate changes. It can also be used in agriculture to predict the crop yield, monitor soil quality, and plan the irrigation based on historical data. Regression can also be used in real estate to determine property prices based on location, area, and nearby facilities. At last, regression is also used in sports analytics to predict the player's performance and help the team strategize according to the historical data and math statistics. Concluding this, linear regression helps us understand and predict the relationship between the two variables, x and y. Also, the best fit line represents the overall trend in data by approximating the relationship between the output and the input variables. The loss function measures how well this best fit line would fit the data by calculating the total prediction error. And for minimizing this loss, we use the gradient descent, which minimizes the loss by iteratively adjusting the slope m and the intercept c to find the optimal line. And at the end, we get the optimal line, which would be used for accurate analysis and prediction. So that's all. Thank you.